Hi, everyone. So we are going to be looking at the topic chemistry of life today. It eventually is going to tie into the digestive system, but specifically for today, we are looking just at chemistry of life. So before we can understand more biology, we actually have to understand just a little bit of chemistry to, like I said, help us better understand how our bodies work, or in this case, we're going to be using the digestive system as an example of how our bodies work in terms of the chemistry behind it. So chemistry is talking about chemicals and how different chemicals react with each other. And when you break chemicals down, we create what are called atoms and molecules. And so that is what we are going to be looking at today. So in terms of this unit overall, there are some large questions that we should be asking ourselves as we go through it. And number one is, what are we all made out of? That's going to be what we are focusing in on today. These other three questions are going to come later when we focus on the digestive system. So those other three questions are, why do we need to eat? So like, why do we get hungry? Like, why do we put food in our mouths? Number three, how do our bodies use the food that we eat? So again, like, why are we eating in the first place? And then number four, where does poop come from? I mean, like, it comes out of us, but where is it being made inside of us? So like I said, we are going to be focusing in on question number one specifically today. So let's get into this chemistry of life. Now, in terms of where we are on the spectrum of small to large, for the previous unit for the nervous system and just body systems overall, we were definitely looking at this large section over here. So the entire organism, organ systems, and then organs, maybe some tissues. For this particular unit, for chemistry of life, we're going to be looking at the smallest stuff. So an atom, molecule, macromolecules. We might get a little bit into organelles, cells, tissues, organs, organ systems as we move into the digestive system. However, just for this area right now, we're looking at this small stuff over here, which means everything we're talking about, our eyes can't actually see. We would need microscopes or other tools to help us visualize what's going on this end of the spectrum. All right, so let's start with the smallest of the small and build towards bigger. So an atom is the smallest unit of matter, which means that anything that you see anywhere, any item you're looking at, it's made out of atoms at its core. So, pack of gum, the actual pack is made out of atoms. This book, made out of atoms. My glasses, made out of atoms. Myself, I am made out of atoms. So if you break down anything small enough, it's made out of atoms. And now we say that atoms can't be broken down by chemical means. So this means that you cannot physically pull apart an atom. We can make an atom explode with an atomic bomb. That's how atomic bombs work. But that is a chemical reaction to make that happen. So we're using chemicals to pull the pieces of an atom apart from itself. So basically, like I said, anything and everything that you see in this world of yours, it is made out of atoms. Now, let's just take a look at the structure of an atom. So, like I said, it is the smallest unit of matter that cannot be broken down by chemical means. But because we are able to break it down by chemical means, by making things go boom, we know that atoms are made out of some smaller particles. So, there are three parts of an atom. The first part is called a proton. Now, proton is a positively charged particle. So proton positively charged. It is in the nucleus of the atom, or the center of the atom right here. So our protons, according to this diagram, are these red circles in here. And protons, they have a positive charge. So if you would like to abbreviate a proton, you can always write P plus as an abbreviation. The next part of an atom is called a neutron, and this is a neutrally charged particle. So neutron, neutral. So NEU, NEU, they sound and look similar. Neutron is a neutrally charged particle. Again, it's in the nucleus. That's going to be these green circles right here. And you can abbreviate it with the letter N for neutron. So protons and neutrons, they are in the middle or the nucleus of an atom. And we're going to come back to what that means in a second. But the last part of an atom is called an electron. So an electron is a negatively charged particle, and it orbits around the nucleus. So these yellow circles are meant to represent your electrons. You can write it as an abbreviation with the E minus. And these, so if you think about it in terms of like a planet and a solar system, our nucleus that's made out of protons and neutrons would be like the sun, and then the electrons would be the different planets that orbit around the sun. So that would be the basic structure of an atom. Now, it's important to understand this structure because depending on how many protons, how many neutrons, or how many electrons an atom has, that gives it different characteristics and different properties. So atoms are classified in terms of how many protons they have in their nucleus. So when we count how many protons they have, depending on that, that gives us a different type of atom. Now, when we have these different types of atoms, again, let me get my face out of the way for you. Oh, it doesn't fit anywhere. Oh, well, you're going to have my face in the way. So different types of atoms are called elements. And hopefully you've seen what a periodic table looks like before. And these are all the different types of atoms or all the different types of elements that we currently know of. We are still finding new elements. However, a lot of them we have to create through some very crazy processes, and they only last like a fraction of a second, but they existed at one point in time. However, all of the elements we're going to be talking about this year, they are what I would call naturally occurring elements. So this idea of having different amounts of protons gives us different types of atoms or different types of elements. In this top corner here, you see a 2 for helium, a 10 for neon, a 5 for boron over here. These numbers in this corner will tell you how many protons that specific element has. So one atom of nitrogen will have 7 protons in its nucleus. And it should also have about 7 neutrons and about 7 electrons. We're not going to get into too much detail. That's next year. That's for your chemistry teacher. But just knowing that these numbers do represent something is good and will help us out. Now, like I said, we are learning about chemistry for biological purposes. So there are 6, am I in the way again? No. There are 6 elements that you need to be aware of for biology. And those 6 elements are sulfur, phosphorus, oxygen, nitrogen, carbon, and hydrogen. So over here, you see the abbreviation for each of these elements: S for sulfur, P for phosphorus, O for oxygen, N for nitrogen, C for carbon, and H for hydrogen. And if we come back to the periodic table over here, we can find all of them. So sulfur is right here. It would have 16 protons. Phosphorus is right next to it. It would have 15 protons. Oxygen is right above sulfur. It has 8 protons. Nitrogen is next to oxygen with 7 protons. C is right next to that with 6 protons. And last but not least, hydrogen over here has 1 proton. So those are the 6 elements that we need to be concerned with for biology. There's only 6, and you don't really need to memorize. Of course, this would happen. There we go. You don't need to memorize the numbers. However, you do need to remember the actual names of the elements. So you'll notice over here that I have them arranged into an acronym to help you remember. So I have the acronym SPONCH. So if we take the abbreviation of each element and write it out in this order, I created the word sponge for you. And so this is just a way to help you remember the 6 elements that we use in biology. The idea is on the MCAS, they're going to ask you a question: what is this substance made out of? Your answer choice can only contain elements from sponge, and you will get practice with this later. So here are also some pictures of what each element looks like. So sulfur tends to be a very soft, solid, sort of like a chalk-like consistency. It's yellow. It smells really, really bad. It smells like rotten eggs. So you actually have sulfur in your farts, and this is what makes your farts smell so bad. Next up is phosphorus. That's this one right here. It can come in different colors. It can come in different consistencies. Some of them are toxic. Some of them are non-toxic. But here is an example of phosphorus. Now, oxygen over here, oxygen is a colorless, odorless gas. It's the air that we breathe. So it's constantly around us. We don't see it. However, it is highly, highly explosive. So that's why I have a big boom picture right here for oxygen. It makes things explode. It's also what's in like grill starter fluid and some other types of like aerosol cans. And that's why they say don't light it on fire, because it's highly explosive. Now, the other part of this is that you actually have oxygen in your farts. So technically you are able to light your farts on fire. Please do not try this at home. Yes, there are videos on YouTube. No, I am not telling you to search them up. One thing to keep in mind though, if you don't push hard enough, the entire fart won't come out. And like I said, oxygen is highly flammable, highly explosive. So the fire can shoot into your tushy. And then if you push too hard, you might poop yourself. So I'll leave that there. Next up is nitrogen. This is a picture of liquid nitrogen right here. Usually, again, it is a colorless, odorless gas. However, if you bring down the temperature enough and put enough pressure on it, we can turn it into a liquid. And this is actually what we use to make those ice cream things called Dippin' Dots. That's how it freezes so quick and hard. The other thing is, because this is so cold, if you were to like dip anything in it, it would completely freeze in a second. So if you were to like dip a person in there, they'd be dead in a second, completely frozen. You'd be able to take a little pick and like chisel them, and they'd just like, fall into millions of pieces. Over here, this is going to be a picture of carbon. So carbon can come in many different forms. It's very versatile. Many things are made out of carbon. So many organic substances, that's anything that is alive or living, usually has carbon as a part of it. So this is showing you different examples of carbon. You can have graphite, which is the stuff in your pencil. That's little sheets. That's how pencils work. So when you rub your pencil on the paper, the little sheets of carbon brush off on the paper, and that's how you leave your mark behind. They can turn into diamonds. They can turn into, I already said graphite, coal. So we burn coal for energy. Those are just some examples. And then last but not least, hydrogen. It burns purple, which is kind of cool. Again, colorless, odorless gas. It's there. Okay. So once we have our atoms or elements, we can put them together to make molecules. So a molecule is 2 or more atoms that have been bonded together. What bonding means is they share electrons. So those things that orbit around the middle of your atom, if they orbit around the middle of that atom, and then they also orbit around the middle of another atom, the 2 atoms are sharing that electron, and that also binds them together. So some examples of this would be a water molecule. Of course, my head is in the way. An oxygen molecule. So this is the air that we breathe. It's 2 oxygen atoms bonded together. You can have a water molecule, so stuff that we drink. And you'd have 1 oxygen atom bonded with 2 hydrogen atoms. And then another example would be carbon dioxide, so the air that we breathe out. And you're going to see 1 carbon atom bonded to 2 oxygen atoms over here. So these are just a few examples of small molecules that we come into contact with on a daily basis, if not like a second by second basis. Now, when we are looking at different types of molecules, they do have different types of properties. So one property is to measure, sorry about the beep. One property is to measure what we call the pH, and this measures how acidic or how basic a solution is. So acids, they tend to be things that burn you. So acids can like burn through your clothes, they can burn your skin. Some examples of this would be like citrus fruits like lemons and oranges. Tomatoes are very acidic as well. Bases tend to have more of like a slippery type of feel to them. So things like soap, dish detergent, laundry detergent, body wash, all of those things have more basic properties and they have that slippery feel to them. Now, like I said, looking at the pH can tell us different properties about these different types of molecules. And so as we go through the year, I might reference this and give you an idea of what the pH of a certain substance is. So what you would need to know is that the average body pH is around a 7. What does that mean? So if we look at our pH scale over here, it goes on a scale from 0 to 14. So it's like a little rating system. Now, 0 over here is super, super acidic. 14 over here is super, super basic. So right in the middle, our body is a pH of 7 right here. We are neutral. We are neither acidic nor basic. However, we do have some acidic parts to our body. So an example of this would be your stomach acid. It has a pH of 1. So super acidic, and that is the acid that is in your stomach that helps you digest food. Also, your blood can tend to be a little bit acidic, so it might fall under this like pH of 6. Your urine and your saliva are also slightly acidic with a pH of 6 over here. And then you can take a look through all of these different items here just to give you an idea of what is acidic versus what is basic. All right, so this is where we're going to end for today. Make sure that you are either looking back or you have been going through your vocab notebook at the same time. We've had a couple different vocabulary words pop up, so please make sure that you are filling those slides in as you go.